So we're going to continue on with what the derivative can tell us when we're drawing the number line. So if you remember before, what we were doing is we were drawing the derivative number line, so the first derivative, and we would have critical points, maybe a1 and a2, and the derivative would be 0 or it would be undefined. And then we would have pluses and minuses and stuff like that. So this is what we were doing before, was looking at the derivative, plotting our critical points, and then saying, where's a local max or min? Where is the function increasing or decreasing? The next section that we're going to look at, and this is section 4.4, is the shape of the graph. Shape of the graph. So let's think about a function that's increasing. So there are two different ways a function can increase. It can be something like that, or it can be something like that. These two functions are both increasing, but they're increasing in two different ways. So the question is, how do we compensate for that in terms of the derivative? Well, this has to do with concavity. So this is going to be concave down. This would be concave up. It's kind of like if you think about a bowl. This is concave down because the bowl is facing downwards. This is concave up because the bowl is facing upwards. So a graph is concave up when it looks like this, and it's concave down when it looks like this. In terms of the derivative, concavity is given by the second derivative. So concave up, that's the same thing as saying that the second derivative is positive. Concave down, the second derivative is negative. Now in the first derivative we had critical points. In the second derivative we have inflection points. So an inflection point is where concavity changes. So where concavity changes. So we have kind of these corresponding ideas between first derivative and second derivative. And we're going to make a chart of all these things, but a graph is concave up, what you want to think in your head, second derivative positive. Concave down, second derivative negative. Inflection point is like a critical point, only with the second derivative. So this is where concavity changes, so where the second derivative changes sign. So let's kind of write down the corresponding stuff that we have here. So if we want to talk about f of x increasing, f of x increasing means that f prime is positive. We could also say f of x is decreasing. Well, that means that f prime is negative. We have f prime of x is 0 at a critical point. We could also have the undefined one here, so keep in mind that this is really 0 or undefined. What about f of x being concave up? Well, that means that f double prime is positive, which means that f prime is increasing. So increasing means the next derivative is positive, so that's why we have this correspondence here. We also have f of x is concave down when the second derivative is negative, which is the same as the first derivative decreasing. And then lastly, f of x has an inflection point where f double prime changes sign. Okay, so I think those are all the things that we're going to need to know. From the first derivative and second derivative, we're going to be able to answer a lot of questions. So let's just start with doing some examples here. Let's let f of x be 2x cubed minus 2x squared plus x. let's find intervals of increasing, decreasing. We want to find critical points. I want to find any local maximums and minimums. I want to find intervals of concavity. And I want to find any points of inflection. So I want to find all of those things. To do that, here's what we're going to do. If you remember, we had that number line for f prime. I'm going to find the corresponding number line for f double prime. So we're going to find the two number lines, and then we're just going to read off all of our answers. So first, let's find the number line associated with f prime. So the number line associated with f prime means find the derivative. So the derivative here is going to be 6x squared minus 4x plus 1. Set this equal to 0. And now I can try to factor, or I can use the quadratic formula. So this will tell me that x is 4 plus or minus the square root of 16 minus 4 times 6 times 1 all over 12. So how many points do I have? Well, 16 minus 24 is negative, so I have no solutions here. So that means I'm not going to plot anything on f prime. Now I need to know if I put a plus or a minus above everything. So let me plug in a value. How about I plug in 0? If I plug in 0, I'm going to get 1, which is positive. So there's my graph of f prime. Now I'm going to find the corresponding one for f double prime. So I'll do this work here. For f double prime, find the second derivative. So the second derivative would be 12x minus 4. Where is this equal to 0? Well, I'll move the 4 over, so I'll get 12x is 4, x is 4/12, which is 1/3. Now I'm going to test something to the left of it, so maybe I'll test 0. If I test 0, I'm going to get negative 4, which is negative. And now I'll test something to the right of it. How about 1? If I put in 1, I'll get 12 minus 4, which is 8, definitely positive. So I know I was trying to cram all this work into here, but these are the two number lines that I really care about. So finding those two number lines is the most important part. So I'll put those here at the top. So there was my f prime, here's my f double prime. So I had a 0 at 1/3, negative, positive. From these two graphs, I can answer all the questions that I wanted. So the first one was, when is f of x increasing? And when is f of x decreasing? So remember, increasing and decreasing, f of x increasing and decreasing, that means I look to the first derivative. Well, the first derivative is always positive, so f of x is always increasing. So it's increasing on all real numbers, and it's never decreasing. Next thing that we were asked is any critical points. Well, I didn't have any that I plotted, so there are none. What about local maxes and mins? I didn't plot any critical points on my first derivative, so there are also none of those. Now let's look for intervals of a concavity. So f of x is concave up when, and f of x is concave down when. So concavity is the second derivative. So concave up would be where it's positive, so that would be from 1/3 to infinity. Where is it negative? That would be negative infinity to 1/3. And then lastly, do I have a point of inflection? Well, at the point where x is 1/3, I have that concavity goes from negative to positive, so I do have one. It's where x is equal to 1/3. So, just from finding those two number lines, I'm able to answer a lot about f of x. I can say that it's increasing always, decreasing never, it's concave up from 1/3 on, concave down, anything less than 1/3. Point of inflection is 1/3, no critical points, no maximums, no minimums. So that's a lot from just two different number lines. Okay, let's try another one here. So this time, let's let f of x be sine of x plus x on the interval from 0 to 10. And I want to answer all the same questions. I want to know increasing, decreasing, concave up, concave down, points of inflections, critical points, local maximums, and minimums. So I'm going to answer all those questions. To answer all those questions, I'm going to look to my number line. So I'm going to need my number line for f prime, and I'm going to need my number line for f double prime. And we want to make sure and label those so that we can actually know which one we're talking about. So let's look at f double prime first. Or sorry, f prime first. So the derivative of sine of x plus 1 is going to be cosine of x plus 1. Sorry, derivative of sine x plus x is cosine x plus 1. Is this ever 0? So it's 0 whenever cosine of x is -1. Well, if we look to our number line, cosine x is -1 whenever x is pi. When else? Whenever x is 3 pi, whenever x is 5 pi, etc. But what is 3 pi? 3 pi is 9.42, so that's within my interval. 5 pi is not. 5 pi is going to be above 10, so I don't really care about that one. The only time that it's 0 within my interval is pi and 3 pi. So I'm going to cut off my picture because I only want to look from 0 to 10. And I found that it's 0 at pi and 3 pi. Okay, now let's look, let's get my minuses and pluses here. Something between 0 and pi, maybe 1. So f prime of 1, well, that's going to be cosine of 1 plus 1, which is 1.54 positive. Again, I don't really care about the number, I care more that it's positive. Now I need something between pi and 3 pi. How about 4? If I type in 4, I'll get cosine of 4 plus 1, which is, again, positive. And then something between 3 pi and 10. How about 9.9? So cosine of 9.9 plus 1. Is, again, positive. So I found all of my critical points, plotted them, found out when it was increasing and decreasing, so there are my pluses and minuses. Next, I'm going to look to f double prime. So the derivative of cosine of x plus 1 is negative sine x, and I want to know where is that 0. So between 0 and 10, remember that's the only interval we're looking at, or the only x values we want is between 0 and 10. When is sine x equal to 0? Well, it's going to be equal to 0 at 0. When else is it going to be 0? It's going to be equal to 0 at pi. It's going to be equal to 0 at 2 pi. And also 3 pi. Anything larger than that, and it's going to be larger than 10, so we're not going to plot those. So 0, pi, 2 pi, and 3 pi. I'm going to add room here a little bit. Now I'm going to have to plot pluses and minuses between all these. So let's see what the first one. How about we plug in 1? So negative sine of 1 is negative 0.84, so negative. Now something between pi and 2 pi, maybe 4. If I type in negative sine of 4, I'm going to get something that's positive. Now something between 2 pi and 3 pi. Let's see, 2 pi is about 6.78, so maybe we'll type in 7. So negative sine of 7 is a negative number. And then lastly, something between 3 pi and 10. How about 9.9 again? So negative sine of 9.9 is positive. So there's my number line. So maybe I'll write it a little bit bigger here so we can answer all the questions. So I had critical points at pi and 3 pi. And then I had positive, positive, positive. And then my second derivative one, I had points at pi, 2 pi, and 3 pi. And it went negative, positive, negative, positive. Okay, so first, let's look at increasing and decreasing. So increasing means where is the first derivative positive. So f of x is going to be increasing from 0 to pi, not including pi, also from pi to 3 pi, and then again from 3 pi to 10. When is f of x decreasing? Well, this is never negative, so never. What are my critical points, or my critical values? So critical values, remember, was where the first derivative was 0. So my critical values are pi and 3 pi. What else? Local maxes and mins. Well, the first derivative doesn't change signs, so I don't have any of these. Next, when is f of x concave up? And when is it concave down? That would be the second derivative now. So concave up means the second derivative is positive. So that's pi to 2 pi and also 3 pi to 10. And then where's it concave down? That would be where it's negative. So 0 to pi and 2 pi to 3 pi. I'm not including 0 because remember the second derivative was 0 there, so it wasn't negative, so I'm not going to include that point. Lastly, what are my points of inflection? So that's where concavity changes. So it changed at x equals pi, it changed at x equals 2 pi, and it changed at x equals 3 pi. So at those 3 points, I have points of inflection. That means concavity is changing. Okay, let's do one more here. Let's look at the function, a little bit easier function here, 2x squared minus 5. Let's answer all the same questions. Increasing, decreasing, concave up, concave down, local maxes and mins, etc. So I'm going to need 2 number lines. I'm going to need my first derivative, I'm going to need my second derivative. F prime is 4x. That's never undefined, but it is 0 when x is equal to 0. Let's see, I'll plug in something negative. If I plug in negative 1, I'm going to get negative 4. If I plug in 1, I'm going to get positive 4, so negative and positive. What's my second derivative? Well, just 4. That's never 0, so my second derivative will just have kind of positives everywhere. Now let's answer what we're looking for. So f of x is increasing, f of x is decreasing. So increasing and decreasing, that's first derivative. So it's increasing from 0 onwards and decreasing from negative infinity to 0. Do I have any local maxes or mins? Well, let's see. This says that the slope of my graph was negative and then became positive. So that's the local minimum at x equals 0. I don't have any local maximums. What are my critical values? I only had one. That was x equals 0. What else? F of x is concave up, and f of x is concave down. Well, the second derivative was always positive, so it's always concave up, never concave down. And lastly, do I have any inflection points? No, because this never changes signs. It's always positive. So, whenever we're talking about increasing, decreasing, concave up, concave down, critical values, local maximums and mins, and points of inflection, we're going to do the same thing every time. We're going to plot f prime, plot the number line for f double prime, and then read off everything. So, that's our kind of outline here. Maybe we'll write down our steps. Is that whenever we do the increasing, decreasing, concave up, concave down, first thing you're going to do is find f prime of x. Then you're going to say where is f prime of x equal to 0 or undefined. Then you're going to plot your f prime number line. Next, you're going to find f double prime, and you're going to say where is f double prime equal to 0, and then you're going to plot the f double prime number line. If we're looking for where f of x is increasing, decreasing, critical values, what else do we do? Also local maxes and mins. All of these, you're going to look to the first derivative. If you're talking about f of x being concave up or down, or points of inflection, all of these look to the second derivative. So from those, you should be able to get everything. And the next section we're going to talk about how to use this to actually plot a graph. But if you can do these two number lines, you'll be able to plot a graph, no problem.